the first thing you should ever do when you are trying to take a limit is, if at all possible, plug the value in. That's it. If I run into some issues like what we did in our opener, 0 over 0, then I might have to do some algebra to clean it up and get that taken care of. If I run into an issue like undefined, that just tells me it's an asymptote, and I need to figure out where this is headed on each side of the asymptote. But again, if at all possible, the first thing I need to do or should do is just plug it in. So, what is the limit as x approaches -2 on this function? This is not top heavy or bottom heavy or neutral. This is not a shortcut because this is not approaching infinity. Those shortcuts only work for infinity. And we have to have those for infinity because there's no way we can plug it in. We don't have the capability in our calculators to plug in infinity because we can't even get there. So we have to have some other method to do that. Not for this. All I have to do is plug that in and get an answer. I think it's 13. Good? Yep. Done. There's my limit. Nothing fancy, right? Same with the next one. Just plug it in. And get an answer. There's my limit. All right. What if I plug it in and I don't get an answer? What if I plug it in and I get something weird? And that's what's going to happen on these next two. I go ahead and I plug in -2 and I get -2 squared minus 2 times -2 minus 8, oops, no parenthesis there, over -2 squared minus 4. And if that's all done correctly, you get 0 over 0. And that's what I was mentioning earlier. This should raise a red flag in your brain. It should be like, whoa, something's wrong. I can't have that. I don't know if this is 0. I don't know if it's undefined. It is a problem. I need to save the day. Let's fix this up. So I'm going to go in here and factor. Okay, then I just went ahead and I factored. I found two numbers on the top that multiply to be -8. The same two numbers that add to be -2. That's -4 and 2. -4 times 2 is -8. -4 plus 2 is -2. And on the bottom, I need two numbers that multiply to be -4, but add to be 0 because I have no middle term. Or I remember this as a difference of squares, and I take the square root. But I found my culprit. The x plus 2 is what's causing the issue. I have now removed it, and I can retake my limit. So I'm going to take the limit as x approaches -2, but of what's left. And it looks like we get -6 over -4, or 3/2. Pretty much the same thing goes on the next one. I do what I'm supposed to do. I do as I'm told. I take my limit the easiest way possible. The easiest way to take a limit is plug it in. I go ahead. I follow the rules. I'm a rule follower. I plug it in. And again, I end up with 0 over 0. Problem. But we're like superheroes of math here. We're fixers. We can fix this. We fix it by factoring. And I'm going to get x minus 1 times x minus 1 over x minus 1 times x plus 1. And again, I'm just factoring two numbers that multiply to be positive 1, but add to be negative 2. Multiply to be positive 1, add to be negative 2. That's negative 1 and negative 1. Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. Same thing on the bottom. Two numbers that multiply to be negative 1, add to be 0. Because I have no middle term, so it's 0. I cancel out the culprit. Which x minus 1 do I cancel out? It really doesn't matter. And now I'll reevaluate the limit. The limit as x approaches 1 of x minus 1 over x plus 1. And I end up with 0 over 2. Is 0 over 2 an okay answer? Yes, it's a totally fine answer. Because that is just simply 0, so my limit is 0. It's the 0 over 0 that is like, I don't know what this is. Okay? So 0 is fine answer. We got 0, we're good to go. Easiest way to do a limit, plug it in. You don't need to make a big table. You don't need to see a graph. Algebraically, you can plug it in. You just have to watch out for some issues. And that issue, again, the biggest, most important issue is 0 over 0. There is another issue that happens. Remember, 0 over a number is fine. That's just 0. But our other situation that we're going to come into is an undefined situation. And when I graph an undefined situation, that means that I have a vertical asymptote. So when I graph one of these where it's undefined, I have it going maybe in one direction on one side or another direction on the other side. This asymptote blocks it. And so at that value, I can't necessarily find a limit. It's not restricted to this. I could have also a situation where it goes, here's my asymptote, and it goes up on both sides of it. I could have a situation where here's my asymptote and it goes down on both sides of it. I could have it go the other way where it goes up on the right hand side, down on the left hand side. But the key is the asymptote blocks the graph from crossing, and it forces the function to rise either to positive infinity, just hover right next to, get really close but never touch, or drop to negative infinity. And that's our job here. When it's 0 over 0, I have to find out where the hole is, cross it out, reevaluate. When it's undefined, I have to figure out what's happening on each side of that asymptote. And it's a pretty simple job. So I am going to start by evaluating, because the easiest way to take a limit is to plug it in, and I plug that in. I get 2 times 2 plus 5 over 2 minus 2, and I end up with 9 over 0, which is undefined. So what this means to me again is if I were to graph this at 2, I have an asymptote. Blocking the graph from getting there. I want to see what's happening on the left-hand side and what's happening on the right-hand side. And so what I do is I make a little table. Tiny little table. Here I am. And I want to do the limit as x approaches 2 from the left. So I want to just look on the left-hand side, which means I'm going to plug in something a little bit smaller than 2. 1.99 will do. Agreed? A little bit smaller than 2? It's good enough. That's close enough. And then I want to do the same thing on the right. I want to check the limit as x approaches 2 from the right, and that'll be maybe like 2.01. Good enough, pretty darn close, just a little bit bigger. And all I'm looking for is what's happening. If it's positive, if my answer is a positive value, and I don't care what value it is, if it's positive, it's approaching positive infinity. If my value is negative, it's approaching negative infinity. So when I do this, I don't even actually evaluate. I just think of what's going to happen, okay? So if I plug in positive 1.99, that is 2 times 1.99, 2 times 1.99 plus 5 over 1.99 minus 2. And again, I don't need to evaluate this. This is what I'm kind of talking myself through, so no calculator necessary. This is really close to 4, right? 2 times 1.99 super close to 4. Agreed? Makes sense? Because it's 2 times something just under 2, so super close to 4, plus 5. What kind of result am I going to get if I add something close to 4 plus 5? And what I mean is it positive or is it negative? And it's definitely positive. Make sense? Okay. Then I have something a little bit less than 2 that I subtract 2 from. Is my result going to be positive or negative? Negative. Okay. So that means that's a negative here. On this side, I am approaching negative infinity. How do I know it's negative infinity? Because a positive number divided by a negative number is a negative number. Again, I don't care what it is. I just care about its sign. If its sign is negative, it's approaching negative infinity. I want to do the same thing on the other side. I'm going to plug in 2 times 2.01 plus 5 over 2.01 minus 2. And again, I don't care what the answer is. I just care if it's positive or negative so I can decide where it's going. So something a little more than 4 plus 5 is definitely positive. Something a little more than 2 minus 2 is definitely positive. A positive divided by a positive is a positive. And we learned last week when we were doing limits, when we first started them, if the limit on the left and the limit on the right do not go to the same place, what is my answer? Does not exist. Is negative infinity and positive infinity the same place? Nope. What's my limit here? Does not exist. That means on the left, it's dropping. On the right, it's rising. They are not going in the same direction. Okay? So undefined is not the same as 0 over 0. Undefined requires checking around the asymptote to see what happens. So let's do another one. Easiest way to take a limit is how? Plug it in. I get 4 over 0, undefined, meaning there's an asymptote. So I have an asymptote on this graph. At 0, I need to see what's happening. So I am going to find the limit as x approaches 0 from the left, and I need to do the limit as x approaches 0 from the right. So I'm going to go a little bit less than 0. Negative 0.001-ish. Negative 0.01, that's fine. Just something a little to the left. A little to the right. Positive 0.001, pretty close to 0. And then visualize, but don't solve. I've got 4 over negative 0.001 squared. The top is positive no matter what. What happens when you square a negative? Positive. Positive divided by a positive is? So my direction over here on the left is positive infinity. Let's do the right. 4 over 0.001 squared. Top is positive. What happens when I square a positive? Positive. Positive divided by a positive is a positive. So it's going to positive infinity. What is my limit? Positive infinity. It's going to the same place, therefore we call it positive infinity. Technically, people could argue, well, wait, positive infinity is not a location, and a limit has to go to a location. And so really it's D and E, and they're right, that argument is a very fair argument. However, for our purposes, we want to know which direction it's headed. Is it heading towards positive infinity? Is it heading towards negative infinity? Because eventually we're going to get to graphing these, and that's what we want to try and figure out, okay? All right. Let's go ahead and do another one. Easiest way to take a limit. Just plug it in. Let's do it. Negative 3 squared plus 2 times negative 3 minus 3 over negative 3 squared plus 6 times negative 3 plus 9. I believe I get 0 on top. Then I get 9 minus 18 plus 9. I believe I get 0 on the bottom. Oh, shoot. What happened? I have to factor. Nice. Good call. So I'm going to factor this. See if I can remedy this. I've done a lot of factoring. I'm done. Can you guys factor for me? X minus 1, x plus 3 on top. Awesome. X plus 3, x plus 3 on the bottom. Get rid of the culprit. And then I will reevaluate. Ah, shoot. Look what happened. Darn it. So it had a hole. I took out the hole, and now it's undefined in that location. What do I need to do? Check both sides. So I'm going to check both sides of this simplified form. Just going to, on the left-hand side of negative 3, I'll put in negative 3.001. Something a little to the left. On the right, I'll put in something like negative 2.999. Something a little to the right. And again, I do not need to evaluate. I just need to visualize what's going on numerically. So it's negative 3.001 over, minus 1 over negative 3.001 plus 3. All right, is that visible here? Minus 1 on top. Okay. What do I get when I subtract 1 from an already negative number? And by what do I get, I mean what's the sign? Negative. So it's negative on the top. What do I get when I add something slightly less than my negative number? I add a positive. It's going to be negative. Very little negative. What's a negative divided by a negative? Positive infinity on the right. Go through the same process on the left. Negative 2.999 minus 1 over negative 2.999 plus 3. How about the top? Negative. What about the bottom? This side's going to negative infinity. Is it going to the same place? No. What's my limit? Does not exist. Oh boy, I've got another one of those troublesome ones. But I'm not going to worry about it because I'm going to do my limit the easiest way possible, and that means I'm going to plug it in. 2 times 2 minus 4 over 2 cubed minus 6 times 2 squared plus 12 times 2 minus 8. Top is 0. What's the bottom? 0. Darn it. Okay. What do I do? Factor. What if I can't? I might have to long divide. Yeah, yep, synthetic division. Well, what I'm going to do here is I'm going to take the 2 out of the top, because I can. And my guess is, just by looking at this, the problem is x minus 2. Does that make sense? That's what's making the top 0. Which means that there must be a factor in the bottom that is also x minus 2. And I could long divide, or I could do synthetic division. And I'm going to choose synthetic division because I think it's quick and efficient. So I will put 2 here. Remember, that's when x minus 2 equals 0, because that's what I'm thinking is a factor down here. That's what's causing the problem, so I put 2 there. Then this is 1, negative 6, 12, negative 8. Bring down the first. Multiply and add. Multiply and add. Multiply and add. That's what I wanted to happen. So I have the x minus 2 that I took out times x squared minus 4x minus, or plus 4. So this was my work off to the side. Now I'm going to put it back into this original function. It was on top 2 times x minus 2, and on the bottom x minus 2 times x squared minus 4x plus 4, and I can get rid of the problem. All right, so now I'm going to reevaluate the limit. This is the limit. As x approaches 2, of 2 over, I'm going to factor this right away because I can. Looks to me like x minus 2, x minus 2. Does that seem right? I just factored it. I like working with the factored form, and it's only because my math is easier. It's easier to see that that's 2 over 0 times 0. So 2 over 0, undefined. Undefined means I have a potential, not have a potential, I have an asymptote. And so now I need to check both sides. Now the problems that I'm giving you on your notes are honestly like, these are the worst case scenario that you're going to get. Where I get 0 over 0, and then I finally pull that out and it's still undefined. Just know that when you do them on your homework, it's pretty straightforward. Plug it in. If it's 0 over 0 factor, get that out. Reevaluate. If it comes over 0 in the first place, make a little table. So I'm going to make this little table. I'm just going to go right to the left of 2 and just to the right of 2. And then I picture what's going on. I'm plugging it right in here. The top is automatically positive, so that's plus on top. And now I'm going to plug 1.99 into this first thing. What is 1.99 minus 2? I don't care what the actual answer is. I care about the sign. Negative. What is 1.99 minus 2? Negative. So on the bottom, I end up with a negative times a negative, which ends up being positive, right? So this side is positive infinity. Do the same thing on the next side. The top is automatically positive. Let's go to the bottom. What kind of answer do I get if I do 2.001 minus 2? Positive. How about 2.001 minus 2? Positive, right? Positive over a positive, positive infinity. What's my limit? Positive infinity. All right. The last ones that are left are unfactorable and piecewise. Okay? So let's start with unfactorable. I'm going to do the same thing. Easiest way to take a limit is to plug it in. I'll go ahead and I plug it in. I get the square root of 0 plus 2 minus the square root of 2 over 0, which is the square root of 2 minus the square root of 2 over 0, which is 0 over 0, which is a problem. So I am going to try to factor. I can't. So my next option, we've seen it before, we're going to apply it again, and that is to use the conjugate. What the conjugate will do is it'll take care of those radicals in the numerator. So what does that look like? I have the square root of x plus 2 minus the square root of 2 over x. And the conjugate is when I multiply by something that looks almost exactly the same except for the middle sign is different. So I'm going to multiply the top and the bottom here by the square root of x plus 2 plus the square root of 2. And on the bottom I'll do the same thing. On the top, when I multiply that through, color that's going to stand out here. Multiplying a radical by itself drops the radical. Then I multiply it by this other thing, and that's plus the square root of 2 times the square root of x plus 2. And when I multiply the next one here, it's minus the square root of 2 times the square root of x plus 2. And when I multiply the last, I get minus 2. This is why we use the conjugate, because it allows us to cancel out any term that has a radical in it. Where we usually see it is we'll end up leaving the radical in the numerator, but in this case we're going to leave the radical in the denominator. Don't multiply the x through because you can't really. I'm going to bring this over and clean it up a bit. So I canceled out those middle terms. I have x plus 2 minus 2 over x times this ugliness. And on the top, the plus 2 minus 2 cancel. And now I can see the issue, and that's that single x. So that leaves me with 1 over the square root of x plus 2 plus the square root of 2. Kind of a little bit scary and complicated, but just apply the conjugate. It'll cross off the problem. Then I'm going to redo the limit. And I end up with 1 over 2 square roots of 2. going to rationalize that denominator. And that's my final answer. A little complicated, right? What is your other option? Your alternate method for number 9? Whenever you cannot, make a table. However, you thought this was complicated? Try plugging in all those values, just a little bit to the left of 0, and a little bit to the left of 0, and try to keep that accurate. The table is always a backup option, but the conjugate is the way to go. And when I give you your homework, we're going to do one conjugate problem together. Okay? So right away, when we're done with this, I just want to go through that. Sometimes even scarier, however, than these sort of radical kind of things and applying the conjugate to us is piecewise functions. But I want to tell you, piecewise functions are the easiest to work with, other than just a plain old basic function. And they're easy because all I need to know is where I'm finding my limit. And if it's the limit that is approaching a problem area, I just need to check to make sure that on the left-hand side and on the right-hand side, they come together. If I am doing a limit that is not in a problem area, then I just have to pick the part of the function that goes with this particular piece, okay? So, how do I know the issue area? Because that's what that's all about. It says that this graph is a parabola to the right of 1, and it is a line to the left of 1. I know that this is the right y. How is that the right? Is it just a guess, or is the top one always right? Has to do with this symbol. What values fall greater than 1? 2 and 3 and 4 and 5, and those are all to the right of 1, right? What values are to the left of 1? 0 and -1 and negative, and those are all to the left. So I know that this is the left side. If I am taking this limit, the limit as x approaches 1 from the right can be found by evaluating on the right side. Okay? And the limit as x approaches 1 from the left can be found by evaluating on the left-hand side. And my whole goal is for them to match. And if they match, that's my limit. So the limit as x approaches 1 of this function is simply -3. If they don't match, DNE. And again, piecewise is only an issue at the place it tells us it's an issue. It is not an issue at -1. I forgot to put left here. Which part of the function does -1 fall under? The parabola or the line? It's the line, because -1 is less than 1. So I'm going to evaluate this by using the line. And there's my limit. Again, the only issue is going to happen when it happens at the value of interest. All right, let's do our last one. I want to check to see if x over x minus 2 will have the same value as x minus 3 over x minus 2 when x is equal to 2. That's what I want to figure out, because that is the area of interest, and if it actually has a limit, it will come together. So when I plug that in, I get 2 over 0, and I get negative 1 over 0. Both of these are undefined. Oops, undefined. So again, I need to check. I need to check on the left, the limit as x approaches 2 on the left. And I need to check on the right, the limit as x approaches 2 on the right. On the left, it's a little bit less than 2. On the right, it's a little bit more than 2. Again, you don't have to use the values I do, just get a little bit less and a little bit more. But I have to pick the right one. Correct one, I should say. On the left, which of the two functions will I use? It's all about the symbol in this area. Which one's the left function? The bottom one. So I'm going to do 1.99 minus 3 over 1.99 minus 2. I'm going to end up with what? Negative over negative, which is positive infinity over here. Okay, great. How about this side? I'm going to do the top one. So 2.001 over 2.001 minus 2 minus, yeah. What positive on top, that one's positive on the bottom too, I think. Positive infinity. What's my limit? Positive infinity. Okay? Again, the problems that I'm giving you are worst case scenario. Most of them are just going to be plugging it in. You have to factor. There are rare occasions or a handful of occasions that you're going to have to make these tables. Okay, the last one. How about if x is approaching 5? Is that a big issue? No. Which one do I use? The top one, because that's the one that 5 belongs in. 5 is greater than or equal to 2. So I'm going to do 5 over 5 minus 2, which is 5/3, and there's my limit. The only time a piecewise function is a problem is when we are looking at a limit at the place of the breaking point, basically, where the functions change. Okay? All right. As always, I lose my mouse. Oh, right here. Okay. Turn this guy off.